Hi everyone, so welcome to the third lesson for topic 9 complex number in Pure Maths 3. So yeah, let's look at the learning outcome of today. So the first one is use the result that for a polynomial equation with real coefficient, any non-real roots will always occur in conjugate pairs. So you are going to use this conclusion or the result here to help you to solve a cubic or a quartic equation. All right. Okay. So like for example, we learned about a quadratic in P1. So no matter you are doing factorization, completing the square or formula, right? The roots that we are finding are actually all real roots. So even like in P3, when we try to learn algebra, so you use factor theorem or you use long division to help you to find the roots, right? They are always limited to real root as well. So that's why for today's session, we are going to look at how do we solve the kind of equation where you have a complex root. Okay, so that's the first thing. Then the second one is we are going to learn how to find the real roots for a complex number. Okay, so which means, for example, you are given 5 plus 12i. So how are you going to find the square root of this complex number? All right, so that's the two main idea for the lesson today. Okay, so let's start with the introduction. Okay, so for this session, as you go through the handout, right, you should realize that the notes part is actually quite short. So yeah, because the idea is for you to understand the idea, then after that you use the result that you learn and you are going to apply in solving the question. So that's why I wish to put more focus in like the example itself more than like the notes part. Okay, so for the introduction part, right, we are just going to do some recap on the thing that you learned previously. Okay, meaning that with your prior knowledge, then after that we try to add in like some of the new thing that you learn when we actually attempt to this chapter of complex number. Okay, so the first one, let's start with quadratic equation. So we know that quadratic equation have a general form of ax squared plus bx plus c equals to 0, right? So for a quadratic equation, it always have two roots. Okay, so there are three situations or three type of roots that we learn. Okay, so you know that for the first one, we know that it will have two real and distinct root. Okay, so which means if let's say we try to write it out, then it will be having like one alpha and one beta, right? Okay, so we also know that we can check the type of the root by using the determinant in quadratic. Like for example, the first one, if let's say it's a real and distinct, then when you try to solve for b squared minus 4ac, you should get a number that's greater than 0. Okay, then after that, we have two real and equal roots. Okay, so this is the one that you are having alpha and beta as well, but it's just that our alpha is equal to our beta. Okay, so for this one, the determinant will tell you that it's equal to 0. Then you know that the equation have two real and equal roots. Then the last one, normally we will say that no real roots, right? But with the new knowledge that we have now, so actually the more proper way to say is that we are having two complex roots. Okay, so they always have two roots as well, but it's just that now it's like two complex roots. So that's why your answer is, if you are able to recall what we learned in the first lesson, right, you know that for the quadratic equation with real coefficient, you will always have the roots in conjugate pair. So which means if let's say you have alpha is equal to x plus iy, your beta should be equal to the conjugate of your alpha. So which means the other root will be equal to x minus iy, if you can recall, right? So this is b squared minus 4ac lesser than 0. Okay, so now we are going to talk about the idea that they mentioned in the learning outcome just now. So when a polynomial equation with real coefficient has complex root, they must always occur in complex conjugate pair. Okay, so let me try to explain the idea again. All right, so what is important here is the idea of pair. Okay, so you see, the first thing is what is that meant by a polynomial equation with real coefficient? So which means, for example, when we try to look at this equation, our A, B, and C must be real number. So which means that in your equation itself, there is no imaginary number or complex number involved. So which means that when we try to talk about solving an equation in this area, right, we talk about all the equations have the real coefficient only. So which means that if let's say we have something like this, then it's not included in our part here, because this one you see that is like complex number or an imaginary part inside here already. Okay, so that's why for a polynomial equation with all the real coefficient, right, if let's say it has a complex root, they must be in conjugate pair. Okay, why is that so? You see, we can try to imagine it like this. So I try to explain the first idea. So a quadratic equation with real coefficient can never have one real and one complex root. So why is it? So from the first lesson, right, you can already see that. So normally when you have one complex root, then the other will be its conjugate pair. So the idea is like this. So we always say that if let's say a quadratic equation, we have a root of alpha and beta. So when we try to form an equation from these two roots, right, we will always do x minus alpha then x minus beta, isn't it? So you can try to imagine what happens if, let's say, I have one real and one complex. Okay, let me try to do an easy one. We are not saying even complex. We are just saying imaginary enough already. So if, let's say, I have one real, one is going to be 2. Then I have the other one is maybe 3i. Okay, so what happened? When we try to write inside here, you'll realize that you have 2x minus 2, right? Then after that, x minus 3i. So what happened when you try to expand it? So you should be able to see that when you expand it, right, you will have the part where x also got I. Then after that, okay, maybe we expand it. So x squared minus, so you have minus 3i, then minus 2, right? So which means when I write together, then I have 2 plus 3ix. Then after that, minus, so plus 6i. Okay, so you see, your coefficient of x is not a real number anymore. So it's not real coefficient. Then your c is also not a real coefficient as well. So that's why it cannot comes in like one real and one complex. So why is it has to be conjugate? Because when it's conjugate, right, it's able to eliminate each other. So for example, we try to talk about an idea of maybe, okay, negative 1 plus I. So we know that the conjugate will be negative 1 minus I, right? So what happens when we try to write it? So it will be equal to x minus 1 plus I. Okay, then after that, I will also have x minus then minus 1 minus I. So when you try to expand it, then what happened? I have x plus 1 minus I, then x plus 1 plus I. So when we try to expand, right, you can see that they are going to eliminate each other. So x and x squared, then plus x plus ix. Okay, then when we continue, we have what? Plus x. Okay, then after that, plus 1, and then plus I. Then minus ix. Okay, then minus I, and then minus I squared. So you can see that the plus ix and negative ix, they are going to eliminate each other. Then after that, you have plus I, then minus I. So this I squared is actually negative 1, right? So what is this? This is actually minus negative 1. So when we try to combine together, then as a result, what do we get? X squared plus 2x and then plus 1 plus 1. So plus 2 equals to 0. So you can see my equation end up to have no I, because of if let's say if it's conjugate, then it's going to like the B part is going to eliminate each other, then the C part is going to give you negative 1 as a result of I squared. So that's the idea. Okay, so remember the result here. So if let's say you have a polynomial equation with real coefficient, so if it has a complex root, it must occur in complex conjugate pair. So we are going to use this idea then try to apply it in cubic and also quartic equation. Okay, so let's try to look at this. Yeah, so this is a very brief thing that you already learned before. So this we talk about like polynomial equation, right? So the fundamental theorem of algebra states that if a polynomial equation of degree n, so it will has n roots as well. So that's why the degree of quadratic equation is 2. Yeah, the degree meaning that the highest power, if you can remember this term. Yeah. So in this lesson, right, actually it involved some of the things that you learned previously in algebra. So that's why make sure that you still remember those. Okay, so the highest power. So the highest power of a quadratic equation of 2 lah. So that's why it has 2 roots. So same thing, the degree of a cubic equation is 3. So that's why it has 3 roots. Okay, so a cubic equation that has a real coefficient will always look like this. So plus bx squared plus cx plus d equals to 0, right? Okay, so a cubic equation always has 3 roots. So now I want you to try to think of what are the type of roots that a cubic equation will have. Okay, so you can imagine like this. This is a cubic equation, right? So what is, if I try to split it up, then what is the two equation that can make up a cubic equation? So it should be a linear, okay? Then after that, multiply with another quadratic, correct? I just try to put EFG here, right? This is how a cubic equation is going to form. Okay, so the same thing here. Can the ax plus b be a complex number? So this thing go back to the idea, the theory that we mentioned just now. If let's say the equation has a complex root, it must always come in pair. So a linear factor here, which means it will give you one root only, right? So that's why this place, it must be a real one. Then after that, for this part, is a quadratic, right? So remember just now when we try to talk about quadratic, we have like two situations. The first one is either you have two real or you have two complex. Okay, so the same thing. So that's why for cubic equation, you will have two situations. We are not going to talk about whether it's distinct or equal. We are just treating them the same. So we are only differentiating whether real or complex. So now we don't care about whether it's distinct or equal, because for b square, you must remember, right? For b square minus 4ac, it only apply for quadratic equation. And why you can do so is just because of the formula that you have. So because of the square root b square minus plus ac, so that's why you only can do this. So but the other equation, you cannot use b square minus 4ac. Yeah. Okay. So the two situations that you have for a cubic equation, right? The first one is that real and two real. So that's why in total you have 3 real roots. So this is what we always solve in our topic 1 algebra. When you are given like the linear or you are given one factor, then you try to solve the equation. Yeah. Then after that, the second is that you have a real. Then after that, you have two complex. So that's why one real and two complex. Okay. So same thing, and the two complex must come in conjugate pair as well lah. Yeah, so which mean that like in this case, then you have, if let's say this is alpha, then your complex root, it must be one beta, then the other one is conjugate for beta. Okay, so that's the idea. Okay, so you will never have two real roots and one complex root, so as what explained here. Okay, then the same thing now we try to look at quartic. So quartic is degree 4. So which means you have ax power 4 plus bx power 3 plus cx power 2 plus dx plus e equals to 0. Okay, so same thing, we try to look at it like this. So a quartic equation will always have 4 roots as well. Okay, now we try to use the same idea. So what equation made up quartic equation? So you should have two quadratic equation that made up a quartic, right? So which means ax squared plus bx plus c, then after that multiply with dx squared plus ex plus f. So this is how you get a quartic equation, right? When you try to split it out. Of course, you can say you have 4 linear lah, but we are trying to combine them. Okay, so for the first one, what you can have either two real or two complex, right? Then what do you have? Same thing, you can have two real or two complex. So we try to combine them and put inside. So the first idea is that we can have all the roots are real. Okay, Then after that, the second one is that we can have two real roots and also two complex roots, right? So which means, for example, the first one I get the real, two real, then the first quadratic I get two real roots, then second one I get two complex root, or vice versa lah. Yeah. So the last one I can have all the roots are complex root. Okay, so which means if let's say there are four complex roots, so your complex root will always come in pairs, so which means you will have two pair lah. So which means the first one, if let's say you have alpha, then it's going to be the conjugate for alpha, then the next one you have beta, then the conjugate for beta. Okay, so I hope that you can understand the idea of how why the complex number will always need to come in pair and so on. So remember the concept that we are going to solve the 5 example together. Okay, one, the complex number 3 plus 2i is a root for the quadratic equation given, so where a and b are real. So a, find the value of a and b. Okay, so we know that if let's say this is a root for this equation, when you are going to substitute the z with the root given here, it's going to perfectly satisfy inside this equation, alright? So it's the same thing like how you deal with the real root. So now let us try to substitute. So we have 3 plus 2i squared minus 5 plus 2i, 3 plus 2i, okay, then plus a plus bi equals to 0. Alright, so now let's try to solve this. So 9 plus 12i plus 4i squared minus 15 minus 10i minus 6i minus 4i squared. Okay, so you know that later we are going to do comparison, so might as well we just bring this over to the other side, right? So now we can try to solve this. So we have 9 minus 4. So yeah, maybe we can try to group them together first. 9 minus 4 minus 15, then plus 4. Okay, all the I squared, change it to -1. Then after that, plus 12i minus 10i minus 6i. Okay, so try to solve it. So we have -6, and then after that 12, 2, so minus 4i equal to -a minus, sorry, this should be b, I. Okay, so by doing comparison, then we'll be able to see that a should be equal to 6, and then after that b is equal to 4. So what you can realize here is that now what happened is you have 3 plus 2i, right? So the question B, the question 1 is asking that why the two roots are not complex conjugates of each other. So by doing this, why can't we say that this is one of the root, meaning that the other pair of the root is 3 minus 2i. So why the roots are not complex conjugate pair? So you see our equation here, are them all real coefficient? No, so you can realize that your B part is having a complex number. Your C part also got something that's consisted of I. So that's why this is not an equation with all real roots, sorry, with all real coefficient. So that's why the complex number is not going to be in complex conjugates. Okay, so that's why answer for B. So the coefficient of the quadratic equation are not all real. Okay, of the, just write QE, quadratic equation, are not all real. So you can see that for A is real, but for B, C is not real, right? So the coefficient are not all real, so the roots are not complex conjugate. Okay, so I hope that you can understand this idea in a better way. Okay, so now we are going to look at number 2, 3, 4, and 5. So they are going to be related to the cubic and quadratic. Cubic and quartic. Because for quadratic, actually we did some of the question in lesson 1 already, right? Like you can see that the roots are actually a conjugate pair. So in this lesson we are going to focus more in like the cubic and the quartic one. Okay, so let's look at number 2. Okay, 2a show that z equals to 4 is a root for the equation given here. Yeah, so this is what we have learned in chapter 1 before. So we need to use the factor theorem. So if let's say z equals to 4 is a root, right? Which means that we can try to let our equation be the function of fz. Okay, so fz equal to z cubed minus 3z squared minus 3z minus 4. Okay, so if let's say 4 is the root, which means that we should get f of 4 should be equals to 0. So you need to prove that when you substitute 4 into the places here, then you are going to get 0. Okay, so 4 cubed minus 3, 4 squared minus 3, 4 minus 4. So although that you can straight away use your calculator to show that it's 0, but the idea is you need to prove that it's 0, right? So to avoid that they think that you are just writing it, then you write 0. So at least try to do like 1 or 2 more working here. So 64 minus 48 minus 12 minus 4. So here we have 16, then minus 16. So we can get 0. Okay, so since f4 equals to 0, so we know that z equals to 4 is a root. Okay, so this is from the factor theorem. So if you have forget this, then please try to do some revision, yeah, regarding to the remainder theorem and also the factor theorem. So B, find all the complex solution for the equation here. So same thing by using the factor theorem. So if we know that z equals to 4 is the root, so which means that z minus 4 is the factor. Okay, so which means when you try to divide the whole equation by using z minus 4, you should be able to get 0. Then after that, you can get the other factor from your long division. Okay, so we can normally do comparison, or okay, maybe for this question, we try to do long division. Then for the other question, we can try to use the inspection method. Okay, so same thing. So which means that when I try to expand it, so I will have the z cubed minus 3z squared minus 3z minus 4. Okay, then we use z minus 4 to divide it. So we get z squared, okay, over, so minus, then we have z squared minus 3z, so plus z, so z squared minus 4z. So after I minus, then I have z minus 4. Okay, so I end with plus 1. So from here, then you are able to check also lah. So it double confirms you that 4 is one of the roots. So z minus 4, then you get 0. Okay, so which means that now if you want to solve this equation for z cubed minus 3z squared minus 3z minus 4 equals to 0, it will be equal to z minus 4 and then multiply with z squared plus z plus 1. Okay, so which means now we are going to solve this, then we can get our answer. So for the first one, it's going to be easy lah. It's the answer that we have. So z minus 4 equals to 0, so z equals to 4. So this is like the real roots part for the linear factor. So for the other part, equals to 0. So this is a quadratic equation, right? So you can always try to check with your calculator first. So but this one, when you check b squared minus 4ac, then you should know that it will give you two complex root over here. So that's why we just by using our formula then to help us to get the answer. So negative 1 plus minus b squared is 1 squared minus 4ac. Okay, then divide by 2a, so 2, 1. Alright, so negative 1, so 1 minus 4, so you can see it's going to be negative 3. So confirm you are going to have a complex root here. Alright, so over 2. So meaning negative 1 plus minus, I'll get square root 3, then I. Okay, so I hope that now you should be able to see like 3 multiplied with negative 1. So square root negative 1 give you I, then square root 3 lah. Okay, so which means from here, then I'll be able to get my answer is negative 1 over 2 minus square root 3 over 2i. Then the other one is negative 1 over 2 plus square root 3 over 2i. So if you are going to write it again, so which means all the, what's the question here? Find all the complex root. So which means the complex root will be these two lah. So you can just write down the complex root. will be equal to your -1/2 minus, just copy everything again. Alright, so that's the idea for this question. So let's try to look at the next one, which is a cubic question as well. Okay, number 3, given that 2 plus I is a root for this equation, so find the other two roots. Okay, so this question is similar with number 2, but it's just that number 2, you are given the real root, then you are required to find the other complex root, and you can see that the complex root is in conjugate pairs as well. So after that, for number 3, right, this is you are given the complex root, then you are required to find the other two roots. So the first thing that you should be able to check is that by checking this equation, you can see that all of the coefficients here are real numbers. So you do not have any imaginary part inside this equation. So by having the cubic equation with all the real coefficient, you should have a pair of, if let's say that is a complex root, right? So which means that you should have the complex root in terms of a pair of conjugate pair, then after that the other one, it should be a real root. So that's why the other two roots that you are finding is one complex and one real. Okay, so if let's say you are given one of the roots, right, is 2 plus 1, so meaning the other complex root is going to be its pair, right? So that's why it will be 2 minus 1. So by having this, then we also can find out what is our factor already. So our first factor is going to be 2, sorry, we should use z here. So z minus 2 plus I. Okay, then after that, the other one is z minus 2 minus I. Alright, so by having this, we can try to create the quadratic equation that we have. Then after that, we can carry out either long division or by using inspection to get our linear factor. So we can combine these two together, so multiply them together. So z minus 2 plus I, z minus 2 minus I. Sorry, I hope that the z and 2 is not too similar. So z minus 2 minus I, z minus 2 plus I. Okay, so let's try to expand it. So z, I'll try to write like this. So to differentiate your 2 and z. Okay, then after that, minus 2z plus iz. Okay, minus 2z plus 4 minus 2I minus iz plus 2I, then minus I square. Okay, so now we can try to solve it. So z square. Yeah, so when you try to combine, then you should realize that you shouldn't have any I here anymore. So this part and this part, no more. This part and this part, no more. So we can try to, yeah, look at, focus in the other one. So for z, so 4 and minus, this will become -1, right? So that's why minus -1, then you got +1. So you have +5. Okay, so this is the equation that you have for the part of the quadratic equation. So to find the third root, so what we can try to do, so maybe this time we try to do inspection, but it's totally fine also. You can just straight away use this to divide by this, then you get the linear factor. So it's the same thing like what we do for the previous question. So if you want to do inspection, so I think this question is quite easy if let's say we do inspection. So it means that to find the third root, so I'm just going to split them out. So yeah, to find the third root, so you can imagine that for the z cubed minus z squared minus 7z plus 15, right? It will be equal to the quadratic equation that we have here. And then after that, it should multiply with one linear. So we can try to let the linear to be ax plus b. Okay, I hope that you get what I mean here. So after that, we just expand this part. Then after that, we do comparison. So like what I say, is similar with long division. You should get the exactly same answer. Just depends on what you want. Sorry, this should be z. Okay, so you can try to expand it. So az square. All right, then after that, sorry, az cube and then plus bz square. So minus 4az square and then minus 4bz, then plus 5az and then plus 5b. Alright, so by looking at this, then we can try to do comparison lah. So the A part and the A part, so you can see that A should be equal to 1 because here and here, right? So you can try to always check A and B again. So after that, you can see 5B should be equal to 15. Okay, this is the part that without Z, so it should be equal to this. So B is equal to 3. Okay, so if you scared, then you can try to check again. So you can see that here is you left with -1. So when you substitute here, then you have 3. So 3 minus 4 times 1, then you get -1. So it proved that your A and B is correct. Now the same thing when you try to check here also. So when you substitute B, then you have negative 12. Yeah, so -12 then plus 5, you are getting to get -7. So that's why it proved that your answer is correct. Okay, so after you get this, then which means that your third root, it will be equal to the answer of A plus AZ plus B. So Z plus 3. Okay, so this should be the third factor. Yeah, I shouldn't write root. Okay, so after you get this, then now we can try to change it to root. Okay, so yeah, because Z factor, it should be in the form of like Z plus 1, Z minus 1, and so on. So the question wants us to find the other two roots, right? So which means in this case, then the other two roots should be equal to, the first one is going to be Z plus 3. So the roots is -3 lah. Okay, then after that, the other one is what you have over here is your 2 plus I, the conjugate, so 2 minus I. So that's your answer for number 3. Okay, so let us move on to number 4 and look at the quartic equation. Okay, number 4 it is given that Z minus 2I is a factor of the equation Z power 4 plus 13Z squared plus 36 equals to 0. So as you can see, this is a quartic equation with all the real coefficient. So that's why if let's say one of your factor is complex number, so which means that it's either you have 2 complex and 2 real, or you have all complex. Okay, so that's like the idea that you can have. So the same thing, if let's say your this is one of the factor, then which means you can find the other factor also, which is the conjugate pair of this. So if Z minus 2I is a factor, so which means that we also know that Z plus 2I is another factor lah. Must be a factor also. Okay, so after you have this, then same thing, we can try to create the quadratic equation, then we use it to divide. So Z minus 2I and Z plus 2I. Alright, so we can have, yeah, I think this one is easy because plus 2IZ then minus 2IZ, then obviously you can see that already, so you can straight away go to your last part. So minus 4I squared, so meaning it will give you Z squared plus 4. Okay, so this is your quadratic equation. So same thing, depends on you whether you want to do inspection or you want to do long division. It should give you the same answer. Okay, so I think this one, it should be easy if we try to use inspection as well. So let the other factor, okay, the other quadratic factor be, maybe we can just try to put AZ squared plus BZ plus C. Okay, so we try to put them together. So Z power 4 plus 13Z squared plus 36, it should be equal to Z squared plus 4 multiplied with the other quadratic factor. Okay, so we can expand on our right hand side, then after that we do comparison. So which means here we should get like AZ power 4, right? Then after that plus BZ cube. Okay, then after that plus CZ square. So for this part, then I have plus 4AZ square and then plus 4BZ and then plus 4C. Yeah, okay. So actually, why am I writing this like writing it like this every time is that I can see like Z4, Z3, Z2, then I know which one to compare later, then it will be easy. Okay, so which means Z4 and Z4, right? So yeah, if you just make sure that you know how to do in your future, so you can just write lah. So comparing Z4, then you should be able to get like A equals to 1. Okay, then after that, the last part, the 36. So comparing the part for Z0, then you should be able to see that 36 is equal to 4C. So that's why C is equal to 9. Okay, then after that, for the B part, you can see that whether you're comparing Z3 or you are comparing your Z. Okay, then you should be able to see that there's no Z3 and there's no Z as well. So that's why the part that you have B is eventually going to be 0. Okay, so after you have this, then which means that we get our last quadratic factor here already. So now we can try to use it to solve. So Z4 plus 13Z square plus 36 is equal to 0. So when we try to so-called factorize it, then we will be able to get z square plus 4. So the a just now is 1, right? So z square and then b is 0 plus c is 9. Okay, so equals to 0. So now by having this, then we can try to solve it lah. So this is the z square plus 4 is what we have for the first one. So we can just expand it. So z will be equal to positive negative square root negative 4, right? So this is why gives you the answer for negative 2i and also 2i. Okay, then the other one, z squared plus 9 equals to 0. So which means that z is equals to positive negative square root negative 9. So we will have negative 3i and also positive 3i. Okay, so that's why the answer one is to solve this equation. So which means our answer for z, it should be equal to negative 3i, negative 2i, then 2i and also 3i. Okay, so this is the question that you have like 4 complex number for your answer, like 4 complex root. I wouldn't say like complex number lah, because this is like the imaginary number rather than a complex number, but they are complex roots. Okay, so let's go to number 5, the last questions before we move on to the next part. Okay, number 5, given that negative 2 plus I is a root for the quartic equation. Okay, so yeah, given here, so find the other roots. Okay, so this is pretty similar with number 4, but it's just that this is complex number rather than the imaginary number. Okay, so I'm just going to fast forward the working. So you're going to do the working by yourself, then after that, check your answer. Okay, so as you can see, this is like the example of you're having all 4 complex root lah. Alright, so let's move on to the next part, which we talk about the square root of the complex number. Okay, so for the second part of the video, we are going to talk about how to find the square root of a complex number. So there's no much note that involved here. So basically, just to tell you that we can find the square roots of a complex number by comparing the real numbers and by comparing the real parts and the imaginary part. Okay, so the first thing is, let's try to do this. If let's say a is equal to square root b, alright, so what do you think is the square root of a complex number? Will it be a real number or a complex number? So you can see that if let's say my b is going to be a positive number, right, then my a will always be a real number after I do the square root, right? It's just either rational number or irrational number, that's it. Okay, but if let's say b is a complex number now, if I square root a complex number, is it possible for me to get a as a real number? Yeah, it's actually impossible. So what is that? So let us try to explain like this. So it means that if a equal to square root of b, so in another words, a square is equal to b. Okay, so can you try to imagine if let's say a is a real number, right? After you square it, is it possible for you to get a complex number? It's impossible. So that's why a square root of a complex number is also impossible to be a real number as well. So I hope that you can get the idea of it. So that's why a square root of a complex number will always be a complex number also. Okay, so now let's try to do number 6. Okay, find the square root of the complex number 7 minus 24i. Okay, so we can just try to let z be the square root. Okay, so which z is also a complex number lah. So let z be a square root, and then z is equal to x plus iy. Alright, so it means that z is equal to the square root of 7 minus 24i. So we assume that z should be a complex number as well. So x plus iy is equal to square root of 7 minus 24i. So how can we continue? Yeah, we will move the square root to the other side. So which means that x plus iy squared is going to be equal to 7 minus 24i. Okay, so by stopping at here, then you should be able to continue already. So which means you are going to expand it and do the comparison. So x squared plus 2xyi and then plus y squared, y squared. Okay, it will be equal to 7 minus 24i. So let us try to combine. So I squared give you -1. So which means x squared minus y squared plus 2xyi is equal to 7 minus 24i. So by comparing the real parts and the real parts, then imaginary part and the imaginary part, we should able to get two equations. So x squared minus y squared is equal to 7. Okay, then I have second one is 2xy should be equal to -24. So by having this, then I should able to solve my equation. So from 2, then I know that y is equal to negative, so divide by 2, 12 over x. Okay, so by having this, then now I can do my substitution. So 3 substitute into 1. So x squared minus y squared, okay, equal to 7. So x squared minus 144 over x squared equal to 7. So you just continue to solve it. So just multiply everything with x squared, then I will have x4 minus 7x squared minus 144 equals to 0. Okay, so I can do my factorization here. So I'll get x squared equal to, x squared minus 16 and then x squared plus 9. Alright, then I would know that x squared equal to 16 and also x squared equal to -9. So which is the part that you should get? Because after you solve this, then you should be able to get plus -4, right? So for this part, then you are going to get, because -9, so after you solve it, then you should be able to get positive -3i. So which is the part that you should take? So you need to go back to the question, what's your x? So your x is actually a number in z. So x we talk about is a real part, right? So the z cannot have, the x here is the real part of this complex number. So for your x, you cannot have any I also. So it's the same thing for your y also. Your y, it must be a real number as well because you have your I here already. So when you try to solve for your y, it must be a real number. So it put together with I, then it become the imaginary part. If let's say you are getting something with I for your y, right, then I times I, then isn't it you don't have any imaginary number anymore? So that's why your x and y must be both the real number. So by having this, so which means that x should be a real number. Okay, so x is real. So that's why I should choose that x is equal to positive and -4. Okay, so by having this, then now I can substitute back into number 2. So I have is x equal to -4, then my y will be equal to -12 over -4. Okay, so it's equal to 3. So if let's say my x is equal to 4, then my y will be equal to -12 over 4, which give me -3. Okay, so from here I get two answer, and that two answer is basically the square root lah. So which means the square root, yeah, I'm just writing the shortcut. The square root of the square root of 7 minus 24i are going to be, the first one is -4 plus 3i. Okay, 3, then don't forget our x plus iy, right? So you have the I. So the other one is 4 minus 3i. Okay, so I think it's pretty simple. Yeah, so just to show that you can actually check your answer, yeah, because this is the square root of your answer, right? Which means that if let's say you want to check your answer, then you just find the square lah. So which means, okay, let us try to check this one maybe. So if z equal to 4 minus 3i, okay, then this is the square root, right? So which means if let's say we try to square it, then we should be able to get 7 minus 24i. So you can just check like 4 minus 3i square and see what do you get. So we have 16, okay, then after that minus 12i minus 12i, okay, then after that plus 9i square. So you can imagine this is going to be like minus 9, so that's why 7, so minus 24i, so you know that your answer is correct. So same thing you can check for the other, so this is how you check your answer. It should be equal to the answer that after you square it. Alright, so yeah, move on to the next question. Okay, number 7, without using a calculator, find the square root of 3 minus 4i, then solve the quadratic equation given here. Okay, so for the A part, it's actually exactly the same thing like the number 6 just now. So what is important here is I want to show you the part B. Okay, so for the A part, I will just fast forward everything so you can try it out by yourself first. Okay, so now let's spend some time for the part B. So solve the quadratic equation given here. So you can see this is a quadratic equation with all non-real coefficient, like obviously because for all your A, B, C is a complex number. Okay, but then because it's a quadratic equation, so you'll be able to solve it by using the method that you always do. But obviously you can't use factorization to solve this, then completing the square will be kind of complicated because of you need to deal with the I part. So that's why the most ideal one is to do it with formula. Okay, so let's try to solve this. So I'll try to do it in the second new page here because it will be like kind of long. Okay, so let me just try to copy the equation here first. So sorry, it should be 2 minus I. Yeah, then z square plus 4 plus 3iz plus minus 3 plus 3i equals to 0. Okay, so let's try to use formula. So which means for us to get z, we should equal to -b. So -4 plus 3i plus minus b square minus 4ac minus 4a and then c. Okay, if you would like to try by your own, you can try it as well because it's the same idea. So it's just that maybe in the middle you might have doubts like how to continue. Okay, so after you get this, then yeah, for the working part you should be able to explore it by yourself. So plus minus, so basically you're just going to expand everything out lah. So 16 plus 24i and then plus 9i squared. Okay, then for the back part is going to be plus 8 minus 24i minus 4i and then plus 12i squared. Alright, so later let's solve it over. So 2 and then 2 minus I. Okay, so let's try to simplify whatever is inside the square root. Sorry, it's a bit ugly there. So plus minus. Okay, so we have, oops, I don't think we need so long. Okay, it's alright. So 16. So we try to group the number 1 together first, plus 9. So negative 1, right? So plus 8 and then plus 12, then negative 1. So for the I part is going to be 24, 24, so minus 4i. So over, same thing. Okay, so when you try to solve it, and you will be able to see that you will get negative 4 minus 3i, positive plus minus. So 16 minus 9, you get 7, 7 plus 8, 15, 15, then 3. So 3 minus 4i. So you'll realize that then how do you try to solve the square root of 3 minus 4i? Yeah, so this go back to the part A question, which you'll try to find the square root of a complex number. So you can see the square root of 3 minus 4i. So it's these two answer. Okay, so now you might have a doubt. So if let's say, because I have two answer for the real roots, just for the square root just now. So am I going to sub it like both here? If I am going to substitute both, right, then isn't it after I get it, then I will eventually get 4 answer? But that's not correct as well, because this is a quadratic equation. So which means although it's complex, it's a non-real coefficient quadratic equation, then but my answer should be having two roots as well. So you can try to see this is a sign of positive and negative, right? So what we can try to check over here is, no, I'm just showing this side for the first time so you can understand why do we just take one. Okay, so imagine if I were to take negative 2 plus 1, then what happens? So when I try to do positive, then I get this, right? So if I do negative, then what do I get? I get 2 minus 1. Then isn't it is the same with this? So the same thing, if I choose to take 2 minus 1, okay, so this is positive, this is negative. So if I try to do plus, then meaning that I will get 2 minus I. So if let's say I do minus, then what do I get? Then I get negative 2 plus I also. Then isn't it is the same with this one? So which means that no matter which one that I take, after I substitute inside, it will eventually give me the exactly same thing. This one and this one, or this one and this one. Right? So that's why either between negative 2 plus 1 or 2 minus 1, you are just going to get anything. Okay, so either one will be fine for you to get your answer. Okay, so now let's continue. So we choose to take the one that 2 minus I lah, so we do not need to deal with the negative. So 2 minus I. Okay, so over 2 minus I. So now we can try to split it. So which means the first one I have minus 4 minus 3i and then plus 2 minus I over 2 and then 2 minus I. Then the other one is minus, so negative 4 minus 3i minus 2 and then plus I. Okay, so now let's try to simplify the answer. So we have negative 2 and then minus 4i over 2 and then 2 minus I. The other one is negative 6, so minus 2i over 2 then 2 minus I. So I think we can try to simplify. So you can see they have the same factor, right? So that's why I can simplify. So negative 1 minus 2i over 2 minus I. Then the other side, negative 3 minus I, then over 2 minus I. Okay, so but we cannot leave our answer like this. It's the same thing like you wouldn't leave a cert in your denominator. So we need to rationalize it by multiplying its conjugate. Okay, so this go back to the lesson 1, like how we do the division. Alright, so the conjugate of 2 minus 1, it will be 2 plus 1. So same thing as well for the other one. Okay, so let's try to solve it. So we have negative 2 minus I minus 4I minus 2I squared. So over then 4 minus I squared. Okay, then the other part, negative 6 minus 3I minus 2I minus I squared. Okay, over 4 minus I squared as well. Okay, so let's try to simplify it. So for this part then, which means that I will have negative 2 then minus 2 times negative 1, so meaning plus 2 lah, so I do not have any real parts anymore, so negative 5i then over, so minus negative 1, so which means I'm getting a 5. So same thing for this side, so negative 6 plus, minus negative 1, so I get negative 5. Okay, then the I is negative 5i, so the denominator is the same. So we can try to simplify. So I have negative I and the other one is negative 1, then negative I. So this will be my last answer for the roots. Okay, so if you are interested, then feel free, you can just try to expand it. So which means by using x plus I, then after that x minus bracket negative 1 negative I. Then you just substitute back, then you see whether you can get the quadratic equation or not. Okay, so you should be able to get it. Alright, so now let's try to look at the last part of our notes. Okay, so for the last part, we are going to talk about the cube roots of 1. So 1 basically represent the number 1. Yeah, okay. So we try to explore the idea by looking at this. So if let's say I have z is equal cube root of 1. So which means that it's the same thing if I say that z cube is equal to 1, right? So when I try to bring it to the other side, then I have z cube minus 1 equals to 0. So this is a cubic equation, right? So by using the theorem that we learned previously, we know that this cubic equation should have three roots. Okay, so obviously this is what we try to do normally. So one of the root is going to be 1 lah. So yeah, that's the idea that we are familiar with. So like square root 1, we get 1. Okay, but from this cubic equation, right, we should have 3 roots. So 1 is one of the roots. So how about the other 2? So you might have a doubt here, can it be like they are all real roots and all the real roots are the same, which is 1? Okay, then let's try it out. So if let's say all the roots are 1, then you have 3 roots. So which means that when you try to put them together, then it will be x minus 1, z minus 1, z minus 1, and z minus 1. So do you think after you expand this, it will give you z cubed minus 1? I don't think so, because obviously you have the term of z squared and z as well. So that's why the idea of having all the roots is real and they are equal is not correct in this case. So we are going to find the other 2 roots now. So we can expect that it's going to be a complex root, because if it's a real root, then which means that by using algebra, we should be able to solve it already. So how can we find it? Then we need to use what we learned in this lesson. So if one of the root is 1, right? So if 1 is a root, so which means that z minus 1 is a factor, right? So now we will carry out the long division. Okay, so the division, z cubed plus 0z squared plus 0z plus minus 1. Okay, so z minus 1. So let's try to carry out the division. So I have z squared, so z cubed minus z squared. So I have z squared plus 0z, so plus z again. So z squared minus 1z. So z minus 1, so I got plus 1. So you can see I can get the quadratic factor here, so which means that it's something that we did not find it yet by using a normal approach. So that's why in this case, then I will have that z cubed, okay, minus 1 equals to 0. It should be equal to z minus 1. Then the other factor is z cubed plus z plus 1 equals to 0. Okay, so how are we going to solve it? Then we do it like how we normally do this. So the first one, then I have z minus 1 equals to 0, right? So z minus 1 equals to 0. So I get the z minus 1, which is the real solution that we always used to have. So the second part is going to be z squared plus z plus 1 equals to 0. So same thing by using the equation. So negative 1, so our b is 1, right? Then b squared minus 4, you see 1 squared minus 4, 1, 1. So divide by 2 squared, which is 2, 1. Okay, so from here, then I'll be able to get negative 1 and then plus minus. So I get negative 3 inside. So square root negative 3 will give me square root 3i and then divide by 2. So which means that the cube root for 1 is actually equal to 1. Then negative 1 minus square root 3i over 2. Then the other one is negative 1 plus square root 3i over 2. So actually you have 3 answers for the square root of 1. Okay, so that's the idea. Okay, so now we will try to use this result to help us to solve number 8. Okay, so solve z cubed equals to 8. So we can do it by using the same thing. So you can imagine that if let's say z cubed is equal to 8, right? So which means that z is equal to the cube root of 8. So one of the normal thing that we try to do is the answer is 2, right? Yeah, but we know that that's not the case. So that's why uh which mean what happened inside is that we have cube root, then after that 8 multiply 1. So cube root of 8, it will give us 2. And then we have the other one is the cube root of 1. So what is cube root of 1? This is what we get, right? So now, which means that the z, sorry, since it's already given it here, so which means that z will be equal to 3 times square root of 1. Sorry, 3 times cube root of 1. So one of it is like 1, so 2 times 1. Then after that, 2 times my second answer. Because this is cube root 1, right? So I'm just going to substitute what I get for the result just now. So 2 multiply negative 1 plus square root 3i over 2. Okay, so by solving this, then I'll be able to get 2 and then negative 1 minus cube root 3i. Then, sorry, square root I. So 2 negative 1, then plus square root 3i. So that's my answer for cube root of 3. Okay, so I hope that you can understand this part. Okay, so that's the part. So yeah, try to spend some time to do your homework and so on, and we'll see you in next week. All right, thank you.